Hey there guys, welcome to this video. This clip that you're seeing right now, I'm actually shooting after I shot and posted the original video and then realized there was a problem in it, so I took it down because I realized it hadn't had any views yet. The problem is that something we're going to do later on requires the setup code to be changed a little bit, so I'm just going to do that real quickly right now, and then I'm going to get on to the rest of the video. I'm just going to stitch this clip on before everything else. So basically this line here and that line there need to be moved up to the intro block and modified slightly. So I'm just going to do that for you right now. Okay, so I cut them, Control X, which is copy and backspace simultaneously. I scroll up past the graphics block, ignore all the changes I've made to the code. We will be getting to those later. And I just put them right at the beginning of the intro block. And then I add the words public static before each of these two lines. Public static. And the word public, I haven't actually addressed it yet, I don't think. But just note that for now, this makes no difference whether or not you put this in like before the graphics block and the main block. It's going to matter, but before variables and something else called methods that we're going to be looking at this video, it doesn't matter if you add this word. I've just added it because in a future video it will be relevant, but you can just not add it for now and then choose to add it when we get to that video if you want, because I'll tell you that we're at that video where this word becomes relevant when we get there. Here, let me just run the code to make sure that it actually works, since I'm editing this live. Okay, I'm just going to test it real quick. Okay, it works. And spoiler alert, there's 2 enemies in the game now, and the character can move on diagonals as well. I don't know if he could do that in the last version of the game, but anyway, thanks. I will now proceed to tell you a lot of the things I've already told you and do some other stuff. Thank you for watching this. Sorry for the confusion. Alright, hello there, and welcome back to another lesson. Today I'm going to quickly show you how to add a second enemy into the game we were working on last time, as well as how to tidy the code up a little bit more. So first I'm just going to run the game to show you how it works again real quick. So I press run. Okay, so here we are. You can see the knight here, and you can see there's 2 enemies. Here's one, here's another. And I can enter any direction I want to go, like on the compass, such as northeast, southwest, east, west, etc. And each time I move, the enemies move as well. And then if I move on to a space that an enemy is on, or I try to anyway, then this purple blast here appears, indicating that I just killed the enemy that turn, and my character doesn't move, and the other enemy moves. As you can see, it was here last turn, now it's here. And then I just keep going, and I get that guy, and it prints out "you win," and the blast indicator appears on the second enemy. Okay, so now I'm going to show you how to create this, or how to modify the code we set up last time to do this. So I suggest that you create a copy of it into a new file and get ready to edit it. So now I'm just going to expand the window here in the center, which is where the code will appear. So I expand it. I make this disappear because it's not something we need right now. That thing I just shrunk into nothingness is not relevant right now. So if we have a look at this file, this is not new. It's the player's X position. This is also not new. Okay, this variable here is new. It just indicates if the player has killed the second enemy. This one, I think, is new. And it just tells the computer whether or not the knight is currently blasting one of the skulls. So the computer knows whether or not to display this purple blast indicator. when we go through the graphics block. This line of code here is just the coordinates of the first enemy. You've already seen this. This one here just creates an int array, which is a concept we went over last time. So if you can't remember what int arrays are, I suggest you have a look at the previous video. So this line of code here just creates another int array, which represents the coordinates of a second enemy. Okay. Let's see. So now we're going into the graphics block. This is the header for the graphics block. This line here. Just going to see if there's anything new in here real quick. Okay. So these two blocks are new. This one here and this one here. Basically what they do is they tell the computer to draw, the entire code in the block isn't new. Like this is not new, but the condition being around it is new. And the reason I've added the condition is that we only want a given skull to be drawn if it has not been killed. In the previous version of the game, it wasn't necessary to test if the skull had been killed when deciding whether or not to draw it, because we would just draw the blast indicator after drawing the skull, so it would cover up the skull. However, because the blast indicator disappears after one turn, if we didn't have this conditional statement here, the skull would just appear in the position where it was when it died forever, which would just clog up the screen and not make any sense. So we've added this condition. This entire block is new. It does the exact same thing as the above block, the above block being this one here. Sorry, this one here. This what I have highlighted now. Yeah, so this entire block is new, but it does the same thing as the above block, except for the second enemy. Note that I have has killed 2, and I'm using the, I have in the parameter here, I have used the variable has killed 2 instead of using the variable has killed. This one's for the first enemy, this one's for the second. And then I also use the array representing the coordinates of the second enemy, not the first one. So here we have enemy 2 at index 0 rather than enemy at index 0 like up here. And that's it. So note that when we draw the blast indicator, we don't have 2 separate blocks like is blasting enemy 1 or is blasting enemy 2, because we don't draw the indicator at the enemy's coordinates. We have it set later on so that in the main block, if the knight kills an enemy, it just sets the coordinates of the blast to the coordinates of that enemy right before it sets the variable saying that that enemy has been killed to true. So the game just draws the blast at those coordinates, or the graphics block just draws the blast at those coordinates here, only if the is blasting variable is true. And then after the turn we want the blast to be drawn passes, this variable here gets set to false, so this block no longer runs. And then this block here is not new. This one we had in the last version of the code. So this here, now we're moving on to the main block. This here is all setup code. These are just some blank print statements so we don't confuse the random junk at the top of the screen with the actual printed script that's relevant to the game. This condition, or this loop, was here before, except the condition has changed because now I want the game to end only if both enemies have been killed, not just one. So before I had while not has died and not has killed run the turn code. All of this is the code that runs each turn, this and everything below it, inside the loop. But now I've changed the parameter to while not has killed and has killed 2. So this condition here can be summarized as while the knight has not died and either one of the enemies is still alive. That's what all of this here sums up to, is basically while either of the enemies is still alive, because it's not both enemies are dead. So while that is the case, run all the turn code. So here's what is in the turn code. So these two things are not new. This is not new either, this line here. This one I'm pretty sure is new. What it does is it sets the is blasting variable to false. And the reason that we do that at the beginning of each turn is that we want the blast to disappear after, like right after the user enters their next decision. So while this line is running, the computer is waiting for the user to press enter to finalize their decision, and the blast is still visible. And then once this line finishes, because the user has pressed enter, we want the blast to disappear, because we don't want it to just linger there after the turn where the enemy, after we've moved past the turn where the enemy was killed. Okay, not new, also not new. Okay, this part here is new, and it does the exact same thing as this part here, except this part here, the one I have selected right now, is a test we had before, and it tests if the player has just moved on to the first enemy's position, and if we need to run the code that runs when the player kills the enemy. And this one tests if the player's just moved on to the second enemy's position, and if we need to run the code that runs when the second enemy is killed. So you see up here we set has killed to true, whereas here we set has killed to true. And we set the position of the blast to the position of the enemy. And here we set the position of the blast to the position of the second enemy. So this here, these two lines, these two and these two, that's what I was talking about earlier when I talked about the code where the position of the blast is set to the position of the enemy. And then, again, we run the code where we set is blasting to true, so we'll actually draw the blast until the user enters their next decision. This is where we just have it redraw everything and jump to the graphics block so that the blast actually appears. And then this just moves the player back to their original position. And then I have code like this where we test if the second enemy dies. Everywhere where I have code where we test if the first enemy dies, you probably don't remember where I put it, but it's in all of the different blocks of code where the player moves. Yeah, you can look at the last video if you want to see all those places. So I'm just going to skip past that. Nothing new here. Nothing new. Oh, nothing new here. Well, not that I haven't explained already. I mean, this is new, but I just explained it to you. Still nothing new here. Nothing new there. Nothing new here. Okay, here. Oh no, hang on. This isn't new either, because this is just the first enemy's decision-making process. And then if we scroll down, this here is new. This is just the second enemy's decision-making process, but it works the exact same way as the first enemy's decision-making process. Except with the second enemy's coordinates. That's the only difference. Everything else is exactly the same. And then, right, this here is the end of the loop. The loop that runs only if either enemy is still alive and the knight is still alive. And this here just prints out game over if if the knight has died, and this just prints out you win if both skulls have died, or if the knight hasn't died. That's all we need to know, because if this loop ended, this loop up here, this isn't the whole loop I have selected. This is just the very bottom of it. But if this loop has ended and the knight is not dead, then we can infer that the knight has won the game. So again, that's why we just have an else statement here instead of an else if. There's nothing new there. Okay, so this is all well and good. It works. However, there's getting to be quite a lot of code. Like, look at all this code I have to scroll through to get up to the top of the main block. This is, I think you could agree with me that this is a bit of a pain to have to look through. Like, if we were to try to add anything else to this game, such as the possibility that enemies could move on angles, or the knight moving in different ways, we'd have to change things in a whole bunch of different places. Like, we'd have to, like, say we wanted to change the way the first enemy moves, we'd have to change this, but not just this. We'd have to change this, and this, etc. Okay, so I'm going to now show you a way to organize this code a bit better so that you don't have to repeat everything so many times, and so that code that you know already works isn't cluttering up the entire code editor. So because it's not cluttering up the entire code editor, we can mainly just see code that we're currently adding, and we actually need to test whether or not it works. Now, the way to do all this reorganizing that I've been talking about is by making your own thing that I have in past and up till now been calling a subcommand. A subcommand. Now, subcommands that's not the real name for those. They're called methods, in fact. But it made more sense to call them subcommands up till now. It was a more self-explanatory name. So what a method is it is many lines of code set up so that they will all run in order when one line, which is the name of the method, is reached in another block of code. So a good example of a time that a method would be useful is if we were creating a game and wanted the computer to repeatedly ask the user which direction they want to move, and then move the character in that direction, and maybe kill an enemy if there's one blocking the way. And we did not want the 100 or so lines of code that all contribute to doing this clogging up the main method, so that we cannot find any other code in the main method. Know anyone who's doing this? So some examples of methods written by those who created Java that we've already seen are sc.nextLine and fillRect. Okay, and also the repaint. That's a method. So when we set a method up, it is called defining the method. And then when we actually use it in the main block by writing the name of the method in there, by writing the name of the method in the main block, that's referred to as calling the method. So an example of a method that we have already defined ourselves and then called is the paint method, which, like I said, is something I've been referring to as the graphics block up till now. So while the paint method does have some special properties in that it can change the graphics being displayed in the top right corner up here, and the and also the paint method has special properties in that when you call it, you don't write paint, you write repaint. That's not actually writing the name. That's very unusual. Most methods do not work that way. And the sc.nextLine method has some special properties in that it can read user input in the console. The methods that we will be defining will just be composed of other methods pre-written by the Java creators that we already have access to and are able to use. So the reason I just said all that is to explain to you that we're not going to be creating any new functions by creating methods. We're just going to be basically stashing all of this code away somewhere that it is not clogging up the main block. It's just to reorganize our code so that we can read it and not have our view blocked by all this random junk. Okay, so now I've opened up a new file where I'm going to be talking to you a bit about methods and showing you another version of this same game, that works the exact same way, except has some of the code hidden away into methods so it doesn't clog up the main block. Feel free to make a new file and copy the game into it to make these changes yourself, or to just work in the file you currently have, whichever you think is best. So, to define a method, type into the intro block, like where you would put a variable, static, like if you were defining a variable, void, this is new, this is something method related. We're actually going to get to what this means in this video, just not right now. Then insert name of the method. After that, insert name here, open bracket, close bracket, both round, then open curly bracket, and then all of the code that runs, like the code for the method, this is where you actually do the defining, this here, followed by another curly bracket. Okay? So for example, I have in my my intro block here, I'm just going to scroll down to it. The example, I'm just going to scroll down to the example I'm trying to show you. Here. I've added the word public. You can just omit that for now, or you can add it before the word static void. For today, it won't make a difference. So, public or not, static void, enemy one move. I've given the method a descriptive name, because the method is supposed to run all the code that moves the enemy. Open round bracket, close round bracket, then an open curly bracket. Oh, it looks like I forgot to make the enemy's positions defined as an array for this version of the program. It looks like I called it EX. Oops, I'm just going to quickly fix that. Hang on. Okay, I fixed the problem. So, as I was saying, if... well, sorry, I'm not going to walk you through all this code. Just note that this is all of the code that runs when the first enemy makes their decision-making process, or does their decision-making process. So look at all this stuff here, okay? And then I have the same thing for the second enemy's move-making process. I've called the method enemy2move, okay? And then I have put all the code for the second enemy's decision-making process here. This is the close bracket, ending the definition of that method. And if we just go down to the main block, oh, looks like here in the graphics block for this version of the code actually changed the way the blasting code works. Anyway, you can just ignore that. It's not relevant to anything. Anyway, I go down here. Okay, so ignore the way that this is labeled for now. Just assume that this variable here, it will always be true if the player actually moved, and will be false if the player entered some invalid input like X or something instead of N or E. So it tests if the player did in fact move and didn't just enter an invalid input, have both enemies move. So look, this is much more concise inside the main block. So if we want to write new code, now we can test it more easily without having a bunch of other junk in the way. Okay, also note that I wrote the word public before the word static with a lot of my variables, at least in this version of the program. I don't know if I did it earlier. Note that, like with methods, if you put public static versus just static, it makes no difference for now. It will in later versions of the code in a future video, but I will explain it to you by then, so it won't be a huge deal. So that's how this works. Now I'm going to talk you through creating a different type of method, one that doesn't just run a bunch of lines of code when you type the name, like this one here. So while it does run a bunch of lines of code, it will also replace its name with a value that it determines while it's running. It will replace its name with a value in the code, such as this method here. See, I have Boolean player moved equals make player move. So this method here both moves the player and then replaces itself with true if the player entered a valid input and false if the player did not enter a valid input. So if you want a method to replace itself with a value, you replace the word void with whatever type of value you want it to replace itself with. In the case of this method, it was a Boolean. So if I just scroll up to the place where I defined it, here, see I have public, irrelevant, static, very important, don't forget this part, Boolean instead of static void. I have static Boolean, make player move, and then the line of code that I typed to have it actually do the replacing itself part in the code where it's called, that on that line, here's how I do it. Let me just scroll down to a part where I do that. Hang on, where do I do it in this method? Hang on. Right, so I have all these conditions testing if, oh no, sorry. Right up here at the top, I have one condition testing if the player entered this valid input, northeast, and then another one testing, nope, not there. Another one testing if they entered northwest, another one testing if they entered southwest, etc. Okay? And then here at the end of all that, we get to the else block. So that's if the player didn't enter any of the valid inputs, have the game print out the user, I'm sorry, I don't understand, say again. Oh, this is supposed to say the character, but doesn't matter. I think you know what it's supposed to mean. So the user, I'm sorry, I don't understand, say again. And then return false. This is the new line. A line where you type the word return is a line that tells it to replace itself in the place where it's called with a value. And then the value that you type after the word return, that's what it replaces itself with. The other thing you need to note about this return line here, this return statement, it stops the method from doing anything else. So if you have a return statement, the method will not continue to run. So if I had a bunch of code after this else statement, but this else statement actually got executed, and then this line got executed, all the code after it would not be executed. So this return true here is not executed if this is executed. And then this here, this is always executed if this is not executed. So also note that when you write a method that has a return type, that's what it's called when it returns something, when it returns a value, you cannot allow it to run without returning something. So I couldn't, like, if I removed this and then ran the code, we would have a crash because there's a case where it doesn't return anything. Because if this doesn't run, this block here, including this bracket here, this bracket, if all this doesn't run and this weren't there, this entire method wouldn't return anything and the computer would crash. So we have to make sure that a method with a return type will always return something. So just to be safe, it's often good to put return some value right at the end of the method, right before the final close bracket. Now I'm going to proceed to show you another type of method, or something else you can do with methods more accurately. And what that is you can set them up to work even if you don't know which values you're going to have them doing their math with when you define them, and which values they do their math to changes depending on when they're called. Like you could call it in one place and have it use certain values for its math, and call it in another place and have it use a different set of values for its math. So like if some condition, call method x using the number 60 or the variable x, or the variable I. Let's not give the variable in the method the same name in this fictitious example. Else call the variable x with the number 70 or the variable z. So here is the way you do that. I'm just going to scroll up to the top. So you type static, insert return type here, insert name here, just like usual, but then open round bracket, insert a value type here, insert temporary name here, then a comma, insert another value type, insert another temporary name, close bracket, and then in curly brackets the code that actually runs when the method is called. So I'm just going to elaborate on that a bit, explain it a bit more thoroughly and with an example. So if you need the method to do math with two ints, then you'd have int, insert a temporary name here, and int, insert another temporary name here. If you needed to use one string, you would just have string, insert a temporary name here, and then nothing here, and then just the round bracket. And if you needed like two ints in a string, you'd have int, temporary name, comma, int, temporary name, followed by another comma, followed by a string, and then a temporary name for the string. And then when you call a method of that kind, you have to put in values with the right type, with commas between them, in the order you want them assigned between the brackets. So an example of a method that works this way is the g.fillRect method. Like the way they would have defined that would be static void, because it doesn't return anything, drawRect, int x position, int x position, comma, int y, int y position, comma, int width, comma, int height. And then when you call it, the first thing you put in is the height you want it to use. No, not the height. The x position. Then the second thing you put in is the y position. Then the third thing you put in is the width, and the fourth thing you put in is the height. Okay. And then when you want to use in the code the temporary variable, you just write the temporary name. So say I wanted to write a method that printed out some string that you give it, a number of times that you give it, I could go static string print x times string the words int num times, and then in the method I define a new variable as 0, and then I have a loop where we go while x is less than num times print the words. So see, like I've put in num times where I want the value put in when the method's called. When I want that value used in the code, I put in the temporary name that I gave to that value up here. And then when I want to use the string that was put in, I also use the name that I gave to, or the temporary name that I gave to that value up here. So print the words, increase the value of x, loop back. That's how this method here would work. And then if I wanted to call it, I would do this. I'd say, assume this is in the main block, or any block that gets run. Print x times, open bracket, hi there, comma, 10. And that's how I would do it. That's how this works. When you want it to have values passed to it when it's run. That's what it's called when you put values in between these brackets for it to use. That's called passing those values to it as parameters. Note that if you do pass values to a method like this, if you have it set up this way, I would highly recommend against changing the values of the temporary variables, because for some types of variables, let me back up again. If you call a method like this type of method where it takes parameters, like this, where you just give it constant values, like a string that you define here with quotes, or a number that you define here, it won't matter if you change the values of the temporary variables, it will work just fine. However, if we do something like this, print x times a string, where a string is the name of a string, comma, x, where x is the name of an int, and we were then to change the values. Actually, this is a little bit confusing because I've defined an int x here and used x as a temporary. Well, this isn't actually the temporary name. We're just using the value of this variable, but regardless, it's confusing because there's an x here and an x here. So I'm just going to change this x to a y. Okay, so if we change the value of y, or we change the value of a string, well, no, we wouldn't change those in the method, but if we change the value of the words, it might or might not change the value of a string. I can't remember if it would change the value of a string for strings. And if we change the value of num times, it also might or might not change the value of y. And it also, whether or not it changes the value of the variable that you passed in as a parameter, so not the words, but a string, and not num times, but y, whether or not it changes the value of these variables after the method is done varies from variable type to variable type. So I would strongly recommend against changing the values of the temporary variables. If you do need to use mathematical operations on those variables and store those mathematical operations, like remember them for the purposes of the method, you should create copies of the variables. So this is how you can do it. So for anything other than strings that we've dealt with so far, so for ints and booleans, you can just create a new int. So we could just say like int z. Sorry, let me go up into the method so I can show you what I'm doing. So I could go int z equals num times, and that will produce a copy. And then we could get rid of num times everywhere. We could just go x is less than z, println. Oh, no, that's different. That's for the words. Yeah, and this would have the exact same effect as before, except if we needed to change the value of num times in the variable, or in the method, we could just change the value of z, and it would not affect y. And we could do the same thing for the string, except you produce a copy of a string or a color in a way differently than the way you produce a copy of an int or a boolean. To create a new string, what you do is you say string copy string. That's just a name I'm giving it. It doesn't have to be the word copy string. It could be anything. Look, this is the name. I think you understand what I mean. String, this is the name. Sorry, no brackets there. Equals new string, open bracket, close bracket, the words, semicolon. And this is the way you produce a copy of a string or color. For a color, it would be like color, this is the color equals new color, and then the name of the color here that you're copying. And this is the name of the temporary variable that you're creating, which is a copy. Okay, I think you get how that works as well. I am now going to just advise you to try to clean up your code in any ways you can by hiding the code in methods that work either like this one here, where you put stuff in, like you pass it parameters at the beginning, or where you like have a return type, or where you don't. Just use any number of methods of these different types. And yeah, I'm not actually going to bother showing you any of my solutions. I think you've actually already seen them though. Like I've scrolled through my method. So if you do want to do it the same way I did, you can just look back in this video to the parts where I showed you the methods I have in this version of the code. Thank you for watching. I will see you next time.